scheduling, this is the compilation. Okay, so again with the dynamic code, this is a compilation. Nothing, I have changed the program name. 3 different program names, one is sequential, another one is static, another one is dynamic. You have received a login from CDAC, Param Rudra also. Till 31st you can use. Whoever is interested, you can come and collect. Okay. Actually, before the starting we asked, yesterday only we received the mail with the logins. CDAC Param Rudra, till 31st you can use, August 31st.
In the IP home, dear students, you can log out and complete the presentation and then
So the output will be like this.
once we join, we take the presentation. Okay.
So my matrix multiplication
Shreya, it's clear, Dharmi?
will be like this. Okay. So this is for sequential, the time output is like this, real, user and system.
Shreya, Mithila.
Okay, actual time and the user mode, how much time, system mode, how much time. So this is the split. And in the static and in the dynamic, this is the output. Okay. And can you try, okay, whether it is connected? So write a C program which should print a series of 2 and 4. So make sure both should be executed by different threads. So how will you do it? So one thread should print the series of 2, 4, 6, 8 like that. Another thread should print the series of 4, 8, 12 like that. Okay? How you can implement?
For loops we can use
For that is the sequential procedure. Using OpenMP,
section.
what you need to do?
Series.
What? Private, because for that particular thread it should increment in 2, and the second thread it should increment by 4. Okay, so you need to declare a variable. By default it is shared by every threads by default. Whatever variable you are declaring. Okay, but if you require for this kind of problem, one thread should do completely different task, another thread should do completely different task. You can write different. So here that is printf. So here you need to declare I, id, the increment part. Okay. So here iteration. Iteration index and the thread ID and the increment part you need to declare it as a private variable. Okay. So ID is nothing but the OMP underscore get thread number. Thread number, so ID will be, and then increment will be 2, ID. Okay. Based on that it will be, because if it is thread 0, 2 par 0, so it will be incrementing as 2. Okay. If it is thread 1, 2 into 2, it becomes 4, the increment count. Okay, and then simply we need to printf and then incrementing like that. So the output will be like this. Thread 1, series of 4 is, so need not be sequence, that is thread 0 should come first and then thread 1. It may be any order. So thread 1 is coming first and then thread 0. Okay.
Other program we'll try.
So
We'll try.
okay, so you can try. I'm skipping this part alone, I'm sure. Only 10 lines, you can try now. Connect
All the
Capital serum underscore small serum underscore.
கனெக்ஷன் கட் ஆகாமல் ஒர்க் ஆகுதாம்மா சார்? நீங்கள் ட்ரை பண்ணுங்க. என்ன முன்னாடி என்ன பண்ணுங்க?
பழசு போட்டு
மூவில அதுதான் ஓப்பன் ஆகும். இல்லைன்னா அது சாரி
next.
Ravi sir. Password. Wanted to see the compilation. GCC hyphen FOPN hyphen LM. So you need to add hyphen LM because math power we have used. Hyphen LM because math.h we have included for power function. Completely different private weather test working. Same pattern, simply multiplying based on the thread ID is different.
இந்த ஃபைல் ஷேர் பண்ணுறீங்களா? கொஞ்சம் ஓகே அது டவுன்லோட் ஆகி டெலிட் பண்ணுறேன். நீங்களே சொல்றது இல்லை வந்துட்டாங்க அந்த
மேப் டாட் வச்சு சேஞ்ச் பண்ணுவாங்க சார். ஓகே. ஸோ அதுக்கு அந்த ஹைஃபன் எல்லாம் ஆப்ஷன்.
இதில் எடிட் பண்ணுறது ரொம்ப நல்லா காட்டுங்க. நான் வேர்டில் டைப் பண்ணேன். இன்னும் கொஞ்சம் அப்படியே ஓகே ஓகே.
நெட் வரலையா? இல்லைதான் இருக்கா? அதே த்ரெட்
3 போடுறீங்களா?
3 த்ரெட்ஸ் போடுங்க. Let me post it in GCR so that you can easily try it.
First
2480.
அது ஒன்றும் பிரச்சனை இல்லை. அப்படிதான் வரும்.
இல்ல ஒரு த்ரெட் 2 ஆரம்பிச்சிட்டு அது கீழே த்ரெட் 1 போடுவாங்க.
ஓவர் இன்டர்லீவ்ட் ஆகும். So I have posted the code in GCR also. Both OpenMP and MPA.
இது
So I think Most of you have executed. Shall we go to the next program? Okay, don't see the GCR, you please try this. And if you can't able to figure out, you can open GCR and copy the code and so here you need to understand how the shared variable among the threads should be updated. Like this construct, we need to delete this construct in separate the talks. Some logic we need to use in order to separate the application. Like zero will be executing and the thread 2 will be executing 4 series up to 8, 16. Multiples of 2, right? Multiples of 2. 2 into 3, 6, 16, 15. Give me that. 2 into
open AP space file name .c space -o space finish அங்கே எல்லாம் போடணும். முன்னாடி டாட்டு ஸ்லாஷ் series தான்
So in the last program we discussed about private variable. Now it is shared.
4 to 4
Every threads, how it is sharing and
ஒரு thread concept
critical and atomic directive will be used in order to ensure the concurrency.
ஒரே threadல 2 series குள்ள ஒரு thread கொடுத்தோம்.
So synchronized operation can be done. So this is without using synchronization class. Without using synchronization class, how it will be working? Okay, sharing, even though by default the variable is shared. Okay, but while updating, it won't update correct value. Okay, that is because we are not using the proper synchronization mechanism between the threads. Okay, data arrays exists here. Okay, so this is simply hash pragma OMP value part. It is executing. So the assignment still we are sometimes will be getting the result, correct results that we can ignore, but always it won't come. Okay, and this is with you can open GCR in your mobile and you can look into the program. So inside the private I local sum, I need to use OMP critical. Okay, so privately it will calculate the sum, and what is actually critical in OS we might have studied. So critical means at a time only one thread can execute that particular code. So this critical region will update the sum. Local sum will be added with the global sum. Okay, and thread will come out. Okay, so this will happen in parallel. Okay, with its private set of variables, and this will happen one thread at a time. Okay, because it is a critical region, and the synchronization happen here, and it will come out. Synchronization is nothing but updating the sum. Understood? If you have done means we can skip this program. Okay. So private and then as well as critical. The same data arrays condition can be avoided. Here, that is the aim of this program. So ensure correct synchronization using OMP critical and also atomic. Either critical and or atomic you can use. Here also two variants are there. One is critical inside the for loop and critical outside the for loop, which is better. Outside the for loop, because for loop we can execute in parallel. Only the updation of the sum we need to execute in a critical section. Okay, that you need to understand. If you are moving critical to inside the for loop, it becomes sequential program. Understood? So local sum and finally sum. So now you can read this program and question tests are there. So here reduction we need to use reduction class. So you can understand if you use for the same problem the different classes, you can understand actual purpose and appropriately you will use for the further programs. That is the purpose for the previous and this one. Both are calculating something. So within a single line reduction we can do it.
Open
quotation.
So which program you want to display so that you can know reduction. Only one line, it will be very similar. So private I you need to specify, that is privately handled by each thread, and the reduction is plus sum we are doing. So that variable is sum and the plus symbol is the reduction for reduction. The header files you need to include is this stdio.h, omp.h, and the max num I have defined it as 100.
For each program, you are getting time for real user and system. For each program, you have mentioned the time.
Real time is actually for real. Time dot slash food data execute time dot slash. So this reduction alone you can try, so that we can move to MPI. அதாவது SRM lamb 021 அதுக்கப்புறம் capital SRM underscore SRM
GCC space finding.c hyphen o file அது output files
இப்போ தெரியுதா?
கொட்டேஷன் போட்டு வந்துச்சு லெஸ் தென் இதெல்லாம் பாருங்க ஏ லெஸ் தென் 3 பண்ண ரியாலிட்டி இது மேத்ராட் இல்லைம்மா மேத்ராட் வச்சு யூஸ் பண்ணுவாங்க இது வந்து இது ஸ்டாட்டிக் இது டைனமிக் இது எந்த டிஃப்ரென்ஸ் இருக்குன்னா உங்களுக்கு டைம் கம்பேர் பண்ணுறாங்க பாருங்க டைம் கொடுக்குறாங்க
Static means equally assigned. The iterations, number of iterations will be equally assigned to how many number of threads. Dynamic means load balancing. So we cannot ensure that equal number of iterations will be assigned to threads. Application prediction.
articles time space that is not time
On the go pattern. Completely pattern. Yes, yes. But small example.
attendance யாருக்கு
ஒரே ப்ரோக்ராம் வேற என்ன பண்ணிட்டு இருந்தீங்க இது நம்மள தியரி கரிக்குலம் எடுத்து அந்த இது இதை சொல்லி வருதா ஆமாம் அதில் இதில் வரும் ப்ரோக்ராமும் இப்போ இருக்காதுல்ல இல்லை தேதி மட்டும் இருக்கே இது வந்துச்சு பாஸ் ஆச்சு நாங்கள் சைன் போட்டோம் ஏன்னா ஏதாவது சீரியஸ் இப்போ பண்ணது சைன் பண்ணி கொடுத்தோம்
யாராவது வச்சுருக்கீங்களா அட்வான்ஸ் சீட்டு
நாங்கள்
ஃப்ளைட்டில் பறந்துட்டு வந்துட்டீங்களா
நேத்தோட ஷீட் கூட
இது ஆஃப்டர்நூன்
Which one will get executed? Reduction and critical will be ignored or? Okay.
We can try. Some other number. You can understand which one is executed. Overwriting is happening. Thread ID.
எத்தனாவது
10 threads it is. 10 threads it is contemplating because that was the parallel and vertical. So each thread will be executing one equation. So each thread is updating 10 plus. So 155. 55 is the sum. Plus 10. Plus 10. Like that. So this sum is not showing there. Whatever reduction sum is not showing there, it is getting updated. And you can this as 1 and comma sum 0 also. Now, what is the reduction output? What is the critical section output? You can understand.
Something of the sum.
Reduction.
You don't need a.
No. Inside the problem. OMP is inside the problem. Outside the problem. This way we can critical section outside the problem. Okay, so you have implemented like this. But we need to check for our case, it should be outside the problem. Like this. OMP parallel private, this is separate. And Pragma OMP is separate. Sum plus equal to local.
The local sum will be the private.
Separate. Yeah, local sum is the private. So if you try that, you will be getting what is the real output of reduction and what is the real output of reduction. Actually, other than the comparison, acceleration என்னென்ன முறையில பண்ணலாம் சிம்பிளா பண்ணலாம் ரிவ்யூ பண்ணலாம் இந்த லாபிக் ஆக்சலரேஷன் பண்ணலாம் அதுதான் அந்த டேபிள் தெரியாது வர்க் பண்ணிட்டு என்ன தெரியுது இது ஏன் வர்க் இல்ல
ஜெய் ஈஸ்வர்
இதெல்லாம் அப்படியே பேப்பரை போட்டு
பண்ணலாம் சார் ஆனால் கூகுளோட பெய்டு வெர்ஷன்
இப்போ அவன் டிபி தரான்ல கிளவுட்ல தானே அது
சரியா
ஆமா அங்க ரூம் விட்டு காட்டுது எது சரியில்லை அதை விட 12 கிளாஸ் பாருங்க உள்ளூர் அது கொஞ்சம் நல்லா தான் இருக்கு சார் அவ்வளோ கம்மியாக இருக்கு இல்லை அந்த இந்த டோர் பாருங்க அப்படி 12ல் ஒரு இருக்கு சரி அந்த மாதிரி ஏதாவது டெம்பிள் இல்லை புது டோர் அரேஞ்ச் பண்ண முடியும்னா 1 வீக்குக்குள்ளே பண்ணிடலாம் இல்லைன்னா இதை போட்டுவிட வேண்டியதான் இப்போதைக்கு ரொம்ப மோசமாக இருக்குது பிவிசியா இல்லைங்க எம்பிஐ இதை பார்த்தேன் அது பிளாஸ்டிக் மாதிரி இருக்குமே அதுதானே புரியுது
So similarly, next program, reduction we send.
புரியுது காஸ்ட்லியாண்ணா சரி அதான் இவர் சங்கர்கிட்ட சொல்லுங்க இப்போ செட் ஆகுதான்னு பாருங்க செட் ஆகுதுன்னா சங்கர்கிட்ட சொல்லுங்க ஓகே 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 ஓகே
So shall we go to MPI?
ஆமாம் 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 சரி 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 ஓகே 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 நான் சாயந்தரம் ஆகணும் நான் 5 மணி ஆகிடும் 5:30 மேலே ஆகிடும் ஆமாம் காலேஜில் இருக்கேன் இன்னொரு அதுதான் ஆமாம் ஆமாம் இப்போ இங்கே சீட்டில் போனீங்கன்னா அங்கே அந்த டேபிள்லாம் போட்டு வச்சுருப்பாங்கண்ணா அது எந்த அளவுக்கு முடியுதோ அதெல்லாம் பண்ணி விட்டுருங்க
So hello world program you might have done. MPI, I'm skipping that part.
சரி ஓகே நீங்கள் பண்ணிட்டு இருங்க நான் முடிஞ்ச அளவுக்கு சீக்கிரம் வரும்போது வந்துடுறேன்
And then next one is MPI program to send and receive hello world messages from all other process to your root.
சரி சரி இது பண்ணிடுறோம் ரெக்வஸ்ட் போட்டு கூட வாங்கி
Multiple
வச்சேன் ஓகே
process is sending information to the root. Okay. So MPI underscore init and then com rank, com size, everything is same. So my rank is not equal to 0. You need to send message to the root. Okay, and only the 0th thread should receive all the messages.
Zero then center idella. Not equal to 0.
Not equal to 0 is the sender.
Appa zero.
The question is MPI program to send and receive hello world messages from all other processes to your root. Sending from all other processes except root is receiving all the hello world messages. Okay, so this is easier only. I wanted to discuss one important program that you finally tried. MPI program to send 2 numbers per process to a root process and print the received messages. Now instead of 1 number, we are sending 2 numbers as an array. So what is the see number, buffer size? So number 0, number 1. Any value you can assign. Myself simply assigning my rank and my rank into twice. Okay, that value I am assigning to 0 and 1. You are passing array now. Okay, from the sender process you are passing array now of type MPA underscore integer, and then destination tag, and rest all same. Okay, which destination here is the root. Root I have designated it as 0. For your understanding, I am not simply using in the program construct as 0. Instead of that, root. Okay, and initially root equal to 0. I am not signing. Okay. This also I think you can understand. Okay, we'll go to the next program. Only one program you try by yourself, then you can understand MPA. MPA program to find the sum of ranks of the all process. Okay, so this you can try. This and one more. Point-to-point communication and collective communication. So point-to-point means one by one you need to send. Okay, so my rank is not equal to 0, then I need to send it to root. One by one I need to send it to root, and at the root it will sum. Sum underscore rank plus equal to partial sum. Okay, so this is your point to point. Okay, and this is your collective. Reduce. Using MPI reduce. Collect all the rank or sum. Understood? The difference? Shall we have a break? இந்த program particular try பண்ணுங்க. last ring topology ஒன்னு try பண்ணலாம்.
நான் சும்மா இதுல இருந்து தொட்டு பார்த்து சில்லு நேத்து வச்சுதான் வச்சேன்.
Not updating.
Not equal to 0. அப்படின்னா என்ன அர்த்தம்? 1 2 3 நான் equal to 0 1 2 3 1 2 3 அவங்க ரூட் 0 கொடுத்துட்டாங்க. 0 மட்டும் தான் ரூட்டா இருக்கு. ஈவன் 1 கேன் become the root. ஃபிக்ஸ் பண்ணி ரூட்டா எடுத்துட்டீங்க. அது அதனால வந்து சோ 1 2 3 ஃபர்ஸ்ட் செட் ஃபங்க்ஷன் அத கொடுத்துட்டீங்க. அப்ப 0 ஃபங்க்ஷன் நேம் என்னன்னா ப்ரீடிஃபைன்
Some one value one is not
communicated. உள்ள இருக்க மற்ற வேரியபிள்ஸ் வந்து நீங்க கொஞ்சம் மாத்திக்கலாம். அவங்க வந்து டெஸ்டினேஷன் சோர்ஸ் வந்து 0ன்னா 0 கொடுங்க, 1ன்னா 1 கொடுங்க, 1 இப்படி பார்க்க நமக்கு தெரியாது.
actually the thread is coming and executing before assigning this value. What's happening actually? You are able to understand that before assigning the value, the printf is happening. This for loop is executing. This is sequential.
Yeah.
Okay, and here it is parallel. So this need to be updated in the memory. Okay. Before that, actually execution over, and before updating into the memory, might be this part is executing so that the garbage values are. That is the only possibility because otherwise definitely because output is different, computation is different. Parallel section will be taking place in the CPU. Printf and scanf and the memory rate and all, that is different. Different system call will be calling and it is IO, no? IO or memory actions. That is one. Before that, first thread is coming and printing this token. This value it is sending to the because the first thread is always coming. Processing is one. And it needs to send the updated value to the memory and what is that? Output printf, no output device. So in that processing is happening faster, but this updation is happening slower. So whatever the older value the thread is referring to, that we need to check wait. We need to wait for update and then construct is there. That we can use. Only then it happens we need to proceed with this. Like that we need to do some classes. Python 4. Python கொடுத்தா அப்படிலாம் கொடுக்க வேண்டாம். அப்படியே வந்து இன்டர்பிரிட்டர் தானே. அப்போ நீங்கள் பிரிண்ட் ஆஃப் எதுவும் வச்சுருக்கீங்களா ப்ரோக்ராம் போகணும். எதுவும் இல்லை பிரிண்ட் ஆஃப் இல்லை. அவ்வளோதான் உங்களுக்கு அவுட்புட் ஆகிடும்.
மொபைல் வச்சுருக்கீங்களா? கால் பண்ணிடுங்க. கிளச் ஏதாச்சும் வச்சுருக்கீங்களா?
லாகின் அட்மின் லேயர் அது ஸ்டூடெண்ட் பாஸ்வேர்ட் /student ஸ்டார்ட் பண்ணிடுங்க. Open Google Colab. So you want me to share the code? shared in the GCR that you can download locally and open it in Notepad. Okay, and then the same you can copy it to your Google Colab screen. Admin, huh?
Google Colab எதுல போனீங்க? ஆன்லைன்
Dot slash வராங்க.
ரைட் சைடு சைன் இன் ஒரு இது வரும்.
கூகுள் கோலாப் எதில் நான் போகணும்?
Just you can, but you have to log in with your Gmail ID. Open in Notepad. Okay. Then you can
Google Colab sign in வரலாம்.
I will show it. I'll show you. The same program with the Devi Mahalakshmi.
Yesterday she
So we need to instruct the Google Colab that machine that we are executing CUDA. Okay, so that is the first statement. Percentage write file vector add.cu. CUDA program we are going to. That following code is for CUDA. That you need to indicate through this line percentage write file vector add.cu. Okay, that is the first line, which is in blue color. Have you opened Google Colab, everybody? Please open Google Colab. You need to connect with your Gmail. Log into your Gmail, and then with the help of that you can go to Google Colab. Done now? And whatever I have shared in the Google Classroom, that program you download and open with the Notepad. Open with Notepad.
It doesn't show any indentation. Indentation is not important here, right?
Indentation. It is not required. Python only. Hash you need to remove, that's it. I am repeating. I have posted the CUDA code in the GCR. Okay. Kindly open GCR and download it and open it in Notepad. Okay. Done. That step is done. And through Gmail, that is you. You have logged in through your Gmail, right? Here, file. You can rename the program CUDA something like that, okay? And continue.
Sign in பண்ணுங்க.
Okay, that is what. So here you can rename, and then have you copied the code? Have you copied the code, everybody?
நோட்பேட் போட்டு அதை எடுத்து என்ன பண்ணுவோம்?
Open Google Colab and copy like this. And you can rename in your drive this file. This IPYNB file will be saved in your Gmail drive, Google Drive. Okay, under My Colab Notebooks. By default, My Colab Notebooks will be generated once if you open the Colab and started working.
Extension என்ன பண்ணுங்க? CU file name.
You have downloaded as a text, no? .py you can download. From GCR you are downloading, right? Simply as it is you download. Here it is there. You can download and open it if you and you can copy the code here. Download it as a file.
மேம் மேம் இதில் போட்டேன் இதில் என்ன பண்ணேன் இல்லை இது நான் பண்ணி இது சேவ் பண்ணலாம் அப்படியே என்ன டாட்
That IP வச்சிருக்கேன் அன்டைட்டில் 0 மட்டும் எரியும் இப்பதான் further reference Can I start explaining? Everybody done? Have you copied the code? In the code, in the Colab? Madam? Copied up. Anga Bhuneshwari madam? Copied? Remove the hash. It is prefixing with hash, so you need to remove all hash and it should be like this. So here the first line percentage write file vector add dot cu is nothing but you are telling the file name and as well as it is CUDA code dot cu. Okay, so write file vector add dot cu. The file name you are mentioning here. With the extension, you are telling it as a CUDA. Okay, dot cu. Right. So hash include stdio that you know, and the vector size they are mentioning it as 5. Okay, and the same program has already explained by Devi Mahalakshmi ma'am. Once more I am explaining. So here, this is the syntax for CUDA kernel they used to mention. This is actually CUDA kernel. Okay, this part is CUDA kernel, right? So this is a syntax underscore global underscore is the keyword, and because it is a global code, okay, and void array add, you need to send the pointers and the size. Okay, that pointers is nothing but your main CPU's pointers value you are passing. Okay, and then global block ID, threads per block, and global thread ID. Okay. In GPU, how the structure will be grid, block, and thread. So the hierarchy will be like that. Okay. Inside the grid, number of blocks will be there, and number of inside the block, number of threads will be there. Okay. So in order to identify in which thread we need to port the value. Okay, from the vector we need to port the value to one particular thread. Okay, so for that we require these information: global block ID, threads per block, global thread ID. Okay, so threads per block, how will you find out? Using this formula. So block dimension. Okay, block dimension in 3, because it is 3 dimensions. So x, y, z you are multiplying together in order to find out how many threads in a block. Okay, and then global block ID. So how we can find out the global block ID where we are using? So here block ID z into grid dimension xy. Okay, and then block ID y into grid dimension x plus block ID. Let me show the figure so that you can easily understand.
Good morning, sir. Good morning, sir. Good morning, sir.
here 3D ID is unique within a block, okay, and 2D ID is unique within a grid. So here grid blocks are 2D, okay, and within the block the third dimension is thread. Okay, so here block 0, 1, 1. Under 1, 1, the next dimension it is coming. Okay, the third dimension. So here what we are doing is we need to find out the block ID. Which block we need to find out. Okay, so for that this is the formula.
Next week.
So global block ID is Z dimension, okay, block ID dot Z, okay, into grid dimension XY.
Monday class PMT placement training நம்ம நேர்ல மீட் பண்ணுவோம் கிளியரா சொல்றீங்க
Grid is formula is here. So this is index actually. Okay. Now, do you understand the row major and column major? How we will save the array elements? Do you understand? Row major and column major they used to tell. That is row wise. First row will be in 2 dimensions generally. First row and then second row and then third row, like that we will save it in the memory. Memory is sequential. Okay, one by one we need to store. So single dimension array means no issues. Okay, 2-dimensional array we need to either save it in the fashion of row major or the column major. Okay, so how will you index it? Say for example 2 cross 2 we are having. We usually represent in 2 dimension as 0, 0, 0, 1, 1, 0 and 1, 1. Okay, but in the memory it should be represented as the index 0, 0 will be storing in 0th index. 0, 1 will be storing in 1 index and 1, 0 will be storing in 2, index 2, and the next one is will be storing in 3. Okay, so the consecutive location. So the mapping here is dimension and the index. Okay, that you need to be very clear. Index should be how it gets stored in the memory, 0, 1, 2, 3 like that, and the dimension is 2 cross 2. Understood? For our perception we are having the row and column, and if it is 3 dimension, third dimension also we are giving, but in the memory how it gets stored, that is index. Okay, ID we are calculating, no, that is index. Now clear? So for calculating the index, this is the formula with the dimension. Understood? With the dimension. So here, so what is the what is the index of this block? 0. What is the index of this block? If it is row major, assume it is row major. 1. This is 3, 4, 5. So for finding that block ID, that is the second line is used. Understood? Now understood? Global block ID. Understood? Next, similarly, global thread ID. Global thread ID is third dimension. So X, Y, Z is coming. Third dimension. Okay? So there exists this is actually basic formula. Even I am having problem for working out this. Okay, if you want, I can give that also. So PD of global thread ID, which is equal to MD of global thread ID. This is actually the vector addition happening in CUDA. I mean in GPU, sorry, in GPU. PD global underscore thread ID, which is equal to MD, that is one of the array, and the next array. MD is one array, ND is next array, and the thread ID accordingly they are mapping. Okay, each in different GPU. Okay, or not GPU, maybe block, different block, but with the same thread ID. We are indexing. Okay, right. So finally, we are printing the global block ID, global thread ID with the answer, along with the answer. So this is your CUDA kernel part. Okay. Now, ma'am explained that device to host, host to device, device to device. So that next portion of the code is only that part. You need to allocate memory and you need to transfer the data from host to device, and there you need to launch the kernel. Addition will be carried out, and from there you need to transfer the data to the host, and then you need to print it. And at the host you need to free the data. I mean free the allocation. Understood? That is what happening here. Any clarification? Any other clarification? You look into the code once, and further clarifications I can. In the host we are allocating using MLR, and in the CUDA we are allocating using CUDA MLR. CUDA MLR. First you understand the code, then only if you execute you can be able to understand the output also. Any difficulty?
What is the expected output?
Okay. So till the end of the program you might have copied in that particular code section. The next section should be this is for which NVC, simple that user local CUDA bin NVCC, that compiler it is using, NVCC compiler. Okay, so just you need to check. This is not required, but for your knowledge I am executing this. And what is the version of NVCC, that also you can check. Okay, and here only we are actually executing not of NVCC vector addition.cu -o. I am saving the output file vector add. Okay, so that I am executing, and finally no such. I haven't executed the version. ரன் பண்ணிட்டீங்களா? அது அந்த பாட்டு உங்க இதுல இருக்கும் பாருங்க. So this is your output. நீங்க என்ன வேல்யூ கொடுத்திருக்கீங்க பாருங்க. m of I equal to I, n of I equal to I. the for loop index itself you have assigned to the vector. Okay, and when you are adding together, it is getting doubled. That's it. The answer. The same you can execute in HPC, that login if you are having the CUDA all library files and all using NVCC. Ma'am, before that you need to choose one thing I forgot. Runtime, change runtime type T4 GPU. Runtime. Here, change runtime. In that submenu, you need to choose T4 GPU. One more code segment you can open now. It's not of NVCC. Not of NVCC. NVCC. NVIDIA. And then space. NVCC. Dot. அதிலே இருக்கு நோட்பேட் இருக்கு நோட்பேட் ஓபன் பண்ணிட்டீங்களா go to the notepad go down the vector add.cu last time vector add.cu icon o vector add
is a file
name once you have go to the folder. Save the file name, first global thread ID and global thread ID. Because we are giving thread ID same global thread ID. 3 different blocks. So we are using the same thread ID. So these two added together and it is assigned. So thread ID is same. Here index will be printed, but here the answer. So any of thread ID here. In the location, but now this Lot of which block ID is different. Dimension vector 7 allocation. There are also vector sizes. Vector size, along with vector size. Grid is 1, 1. Yes, now I could have 4 rows, 3 columns. Many blocks we are having. because the dimension here not having this y is actually 2. 1 into this 2 into 1 plus block ID. Like this. I am showing you how to calculate that.
Actually, on the dimension I know 0 0 100 rate out.
Yes, ma'am. Vector size. But you are getting the answer only for 7. 7 only. 12, after 12 you are getting 7. Because that is the kernel. Whatever threads they assigned, it will continue. The slide will ask. Long and thread. Major column major. Block index more. Index dimension
Dimension
0 0 1 0 2 0 2, 3 dimension. 3 dimension. 2 rows, 3 columns. So within grid 2, 3 dimension. 2 rows, 3 columns. So totally blocks 6, 0 to 5. So 0, 1, 2, 3, 4, 5 is the row major order. Column major 0, 1, 2, 3, 4, 5. Row major, always by default it is row major. Similarly, thread ID. Within the block, the thread ID should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0 to 14, row major. So this is the dimension. 3, 5 is the dimension. Index is 0 to 14.
3 rows, 5
Dimension.
possible total
Actual dimension என்னன்னா threadக்கு log 0 அதாவது இங்க வந்து grid 1 ல ஒரே ஒரு grid இருக்கு. ஸோ அந்த grid dimension அப்புறம் block dimension அப்புறம் blockக்குள்ள thread row 4 லெவல் பண்ணுவோம். டியூப்ல மென்ஷன் பண்ணிட்டு 4 gridோட gridல என்ன நம்பர், block என்ன நம்பர், threadக்குள்ள என்ன ரோ, எந்த ரோ, column.
இதுக்கு ஒரு கிரானுக்கு ஒரு கிரிட் தான் கிரிட்டோட
Grid kernel is, you are asking that software part.
இப்போ grid 1 ன்னு grid value 1 ன்னு
Kernel 1 is grid 1. This is mapping. Like we can have
Number of grids we can have.
you can have.
We can have number of grids. So they will be
Or automatically by default what they configure it will take that. Which grid? We can decide by or by default in the program we are not deciding. By default it is taken.
So in the program, ஒரே ஒரு block மட்டும் அடிச்சிருக்கோம். அந்த blockல 5 threads இருக்கும். எடுத்துட்டு இப்போ நம்ம சொன்ன அந்த 6 இது வந்து values வந்து அதை add பண்ணிருக்கோம். அதுதான் link பண்ணுறோம்.
What kernel we are having in our program, that is the software kernel that we assign to GPUs. So GPUs execute one kernel which is a group of tasks. We are having only one task. So kernels are composed of blocks which are independent of group of reactors. Blocks of CPU graphical processing. Parallelization, general purpose processing. The graphical GPUs block, thread and all software.
GPUs execute the
And then here after executing the kernel, we need to device to host we need to PD is your host name, result host name, and P is your CUDA, what is it, where the result is that blocks it.
Is there any way to kind of it's like a replacement of some other materials?
MD is the pointer. We are allocating, we are assigning. And we are having M vector, M N E vector, no? We are assigning M or the source, vector source for addition. So that M is the source here. And here N is the source. And the result you need to give it to value P. That is what here they have mentioned P. This is the destination. That will be copied to the This way you will keep exploring. Your answer is not ready. But it is ignoring, it is not telling the error. What is PD, it is not telling. Because it is declared, no. PD is declared but no values. Actually, I prepared one PPT for you for discussing the article summary. That is what I will say. So let me give the revision about the entire list. Can you listen? Can I have your attention for next 15 minutes? I'll finish it. Okay. So we discussed programs on OpenMP, MPI Kuda, that is over. Now article summary alone I need to do. So before that, some revision what we discussed in this FDP. So I think in the day 2 you might have viewed this. So here the projected performance development of top 500 over the years from 1990 to 2025, not yet released. Okay, so during this region actually expected, this is your expected performance line, but it is well above that line. The high performance computing this performance is giving well above that line, but during the COVID time the performance is delayed. Okay, that you can see here. Okay, and the green color is nothing but your sum of all the 500 performance. Okay, and yellow triangle is your number 1 supercomputer in top 500. That performance, and blue square is the 500th. Okay. And you know very well, world's first supercomputer is Frontier. Usually they rank it based on the high performance LINPACK benchmark. Okay, so and it is 1.2 exaflop it is giving. Next is we should know, right, what is the ranking of Indian supercomputers. Iravar, which is in Pune, that is the ranked first in Indian supercomputers, but in the world rank it is 110 now currently. And Param Siddhi, it is also there in Pune, and it is ranked 2 in India, and it is on the top 500. It is coming up with the rank 185. Okay, and Pratyush HPC cluster, it is not in CDAC, but it is in Pune under the IIT Tropical Meteorology. Okay, they are having this cluster, HPC cluster, and the rank is 3, and so totally first 3 ranked supercomputers are there in Pune. Okay, and in Noida, the 4th, this is especially for weather forecasting, the 4th HPC list. So that is a 4th one, and in the top 500 it is in the rank of 388. Okay, and the source I have taken from this. Okay,
that's good. We have 4 supercomputers under 500.
Yes. And this is about the high performance LINPACK. This is basically linear algebra library. BLAS is actually binary linear algebra library, and also that is nothing but signal and image processing library, VSI here. Okay, so composed of these linear equations and image processing equations and all. Okay, so that is all about high performance link pack, and this is the first program every supercomputer will be executing in order to move the peak performance. Okay, and you can get high performance computing. Anybody, any public can get the high performance computing login through this process. Actually, we applied for you through this. Okay, so nsmindia.in/node205 is your URL. There you will be having a form. You can fill it and you can apply it. This I will share. No need to worry. And these are the number of supercomputers in India by city. So in Tamil Nadu, we are having only in Chennai and Trichy. Okay, Chennai, we are having, I think, 3.8 is 3 supercomputers, and in Trichy, 1. And this, yesterday you have seen, in our Katangalu, we are having a supercomputer with this specification, Star, Comet, Galaxy. So, HPC components, the basic general architecture will be like this. So, you will be having a login nodes. Okay, yesterday in data center, Mahendran sir told that login nodes can have internet connectivity. That's how they are providing more security, that compute nodes or accelerators won't have internet connectivity for security purposes. Only the login nodes having the internet connectivity. We are login nodes. Here we are using. Okay, that is the login nodes. And you know the compute nodes where you are submitting the job. And accelerated compute nodes, GPU, in CUDA you are using. And hardware acceleration is also there. That I will tell you another 2-3 slides. And actually this primary interconnect which is shown in the red color, right? So that is only for administration. We won't use it. We won't transfer data through that. So we will be transferring the, this gray line is for administration. Primary interconnect for data transfer. Okay. So this arrow mark is for gray. Okay. 1 GBE for administration alone. Okay. Right from the management nodes you cannot able to access. Okay. Normally higher position people will be having the login to management nodes. Okay. And local network, that how we are using HPC, which is situated in Katangalattur. Through the direct link we are using this. This is our local network through networking gateway. And this is your hierarchical memory, storage memory. Okay, there for backupping the data you will be having the parallel file system and storage activation. Everything is for storage. Okay, this is backup. This part is entirely for backup, and this is for processing along with the.
One node we say that as a separate CPU, or all the nodes put together we say that as a CPU.
That in the comparison I tell you. These are all compute nodes. One blade server they have shown. That is said to be one compute node. Yesterday we have seen, right?
Master, that is going to act as a.
No, need not be master.
Not necessary to be a master.
Need not be master. Here nobody will be master. Everything is having equal balancing effect. Okay. Right. So this is the software stack. You will be having several divisions. So here performance monitoring, development tools, application libraries, resource management, job scheduling, file system, provisioning and all. So in the performance, under performance you will be having HPCC. I cannot able to remember each and every one. So I have in the document, this also I will share you. I have prepared one document which is having all the information about the software stack. Okay. Okay. Then this also I will share. Okay. Each and every acronym I am having the description. This I will share. So I am skipping this slide. And these are the components, processors, memory, interconnects. Yesterday we have seen in the fiber optic they have shown, the fiber optic cable and all they have shown. So that is accelerators and coprocessors, that is your GPU, TPU or hardware accelerators, whatever it is. Storage subsystem, parallel subsystem, storage accelerators, everything will be coming under that. And the system software, and what we are doing is the applications. Okay. And coming to the hardware acceleration, you might have not familiar about it. Actually, my research area is this one. So here, the hardware field programming gate array will be there. Normal programs what we are executing in the computer is you will be having compilation step and then loading, linking, everything, and then finally execution takes place. Okay, that is your normal flow. Okay, this is your microprocessor requirement specification, programming language code, compilation, executable file, and then it is sitting in the microprocessor for execution. Okay, this is a normal flow. In the hardware, actually, easy people might know, requirement specification that we need to code using hardware definition language. Okay, Verilog or VHDL, right? And nowadays we are using MATLAB also. There also we can do it. Simulink, anything is there. That whatever we are writing in the Verilog or hardware definition language code, directly we can synthesize. Okay. So after synthesizing, we will be having a bit file generation that you can port it in the configure it into the FPGA. So FPGA is for developing purpose you can use. Okay. Once you standardize that hardware configuration, you can go to ASIC, application specific integrated circuit, which can accelerate your code if you want it specifically. Okay. So that is the difference between these two. So hardware acceleration is generally faster. Why? Because we can avoid this compilation each and every time. Storage, everything. Okay. Input, like your AND gate, we are giving input, immediately we are seeing the output. Like that. Okay. No need of compilation, memory access, input, output, nothing. Okay. Through wires, everything is hardware. Through wires we are giving, and immediately we are getting the output. That is the hardware acceleration. So here in the FPGA, shorter time to market and low NRE cost for development. Okay. Later you can go to ASIC, and then suitable for massively parallel applications, and that is what I told. Digital designs directly you can convert it into application specific integrated circuits. So here FPGA, you will be having the components, interconnects. These are interconnects, and the square boxes are your logical blocks. There you can realize your hardware design. Okay, in the logical blocks. Okay, and IO blocks is for sending input and output. Okay, so the entire FPGA, no need to configure it again and again with your hardware design. Dynamically, when the portions of FPGA is executing, okay, so, some hardware operations is carried out, you can configure the other part. Dynamically you can do it. Okay, I have done for scheduling. For this, how to schedule different sections of your code, a big application like your cryptographic algorithms, SHA and all, you can segment into different code blocks. Okay, and that you can configure into different hardware sections, and one hardware section you can port it in. That's what I have shown in the gray regions. This is a part of your SHA algorithm. Understand in that way. And this is another part. This is another part. While during the execution of these parts, I can reconfigure this section. Okay, this is nothing but your dynamic partial reconfiguration. This is also possible in the hardware acceleration if you are employing FPGA, not with ASIC. ASIC once design means that's all. Okay, but in the FPGA you can reconfigure. That is the advantage of FPGA. Okay, so with this I am stopping FPGA and coming to the article summary. First top 500 we have discussed now. So in that, now you can understand which is compute node and which is accelerator. Can you able to tell? Because you have studied that article.
GPU.
Where it is CPU here? Where it is GPU?
The rack computing.
Here?
Each rack there is a computer.
I'm asking here. When posting the article, you are reading the theory part, but you need to look into the diagram more than reading the theory part. So this is your host, CPU host, P9 processor. And these are your GPUs. They have written here.
So we have more number of
6.
GPUs than
Yeah,
CPUs.
I have the comparison study here. So diagrams, you can look into it. So from the diagram, I'm having the comparison chart here. All the 5. Okay. In that paper, we read about Summit, Frontier, Aurora, EL Capital, EOS. Okay. Some of the fields are empty. I couldn't able to find it, that information. So if you come across, you please share. Okay. So from that paper, this was the information I gave. Okay. So this way you need to get the crust of that paper. Okay. So next, summary 2. K-means, everybody knows. Okay, what is K-means? Clustering algorithm. This way it will cluster. Okay, randomly you will be having a data and it will be clustering it into many types. Okay, grouping together of same nature. Okay, so here what we are doing is HPC we are bringing into, and using microservice architecture is very famous in cloud. Okay, we are using that microservice architecture which is very light and independent. So here mainly used for massively distributed systems, that HPC is also. So lightweight communication, and it is independent. Many microservices collaborated together in order to achieve tasks. Okay, independent, it is independent, right? That is about microservice architecture. And AMQP protocol, you will be having 2 things. One is broker. Okay, in the broker, that is actually the enabling part, communication enabling part, broker. In that we are having 3 different terminologies, elements. Okay, 3 different elements. One is exchange, another one is binding, another one is key. So exchange is nothing but the type of communication what you can tell. Okay, so here I have given the type direct, fan out and topic. So direct is nothing but point to point. Okay, different terminology they are giving, that's all. Concept is same. Direct is point to point. Fan out is broadcast. Okay, topic is multicast. Okay, that way you can understand. And binding is routing. Exchange is over. Binding is routing. Okay, in what way you need to route? Based on the point to point, or based on the broadcast, or based on the multicast. Okay, and queue. So it is asynchronous communication like our WhatsApp. So it will be queued up, and the later notifications will be sent to the listener. Okay, listener or consumer, whatever it is. So after reading the notification, the consumer get the. Until then, it will be remain in the queue for that purpose. Okay. So with this in mind, we can execute K-means under distributed. Okay. So here, whatever I explained, it is given in the figure. Binding, exchange, binding, queue. Those are the 3 components of AMQP protocol. And yeah, broker. Okay. And these are the direct, fan out and topic. 3 different. Okay. So here, Q1, Q2. Separately it is sending, point to point. That way you need to understand. And this one is fan out. Fan out means broadcasting. It is sending to all the links. And here multicast means only Q2 it is sending. That way. The difference, no difference in the figure for these 2 types. Okay. Why? Because this is direct, but it is sending to all the queues using point to point communication. Here broadcast. Here multicast, only Q2 it is sending. That way you need to understand. your standard k-means algorithm, which is based on the distance between this element and the cluster center. Okay, that you know. I'm assuming that you know the k-means algorithm. Here, see, your entire data is get divided into 4 parts. Okay, and it is assigning to different nodes. Okay, and broker AMQP is communicating between them. Right. So RDs, RCs, and cards. They are following these terminologies. RDs is nothing but the sum of distance of each class center, and RCs are sum of the data point from each class center, and then cards. So these are some notations we need to understand. Okay, so not difficult. And with this, they are calculating the global RD, global RC, and global card. From that, they are calculating the cluster center. These are summarization or combining the result, convergence happening. So here distribution is happening. Here distribution is happening. Okay, and for only these 4 elements, it is doing. Each and every node is doing. Okay, and whatever individually this is calculated, in the next slide, it is combined, converged, summation they are doing to find the global RDs, global RCs, and global card. Okay, from that information, we are again finding the new class of cluster center, iteration, next iteration, new class of cluster center, and then objective function is also calculated. Understood? Any doubt in this? So this is the and the exchange of messages is this one. So host to VPUs, virtual processing units. Okay, how, in what way it is. So here, input image is divided, okay, and it is sent to all other 4 virtual processing units. And again, so initialization of class centers also it is sharing, and then after this, it is doing segmentation, and it is sending back the result, RCs, RDs, and cards. Okay, and in the next step, sending the new class centers from the global RD, RC, card after calculating. So this calculation, it is happening at the host. This calculation. Okay, and again using microservice architecture, it is exchanged to the virtual processing unit. Here, it is sending. Okay, so the convergence part, the host is executing. Okay, and the parallel part, it is distributing to the virtual processing unit through microservice. Understood? Any doubt? Can I move to next one? Next is very easy, but that article I haven't posted in the GCR. This is the usual C program for MPI. Okay, all the 6 functions is called MPI init, comrank, and then send, receive, finalize, everything is there. And in Python, it is very simpler. That's what when we teach students, we should teach first C and then Python. If we teach Python and then C, they definitely won't do C. They feel it difficult. Okay, so this is your normal MPI 4. So here only 2. Here initialize, finalize, by default it will, that library will take care. Only send and receive matters. In send and receive also, you will be having 2 different communication routines. One is in uppercase, another one is in lowercase. It is given in the paper, I will share that. Uppercase routines are working with contiguous memory location. So only Python objects is supporting, NumPy arrays and all. If you want to work with objects other than Python, say for example some other third party, okay, then you need to go for lower class function, that is non-contiguous memory support will be provided. Okay, so but in the HPC it is advisable to use uppercase methods in order to get the superior performance. Okay, that is it. So this information also there in the paper. Okay. So MPI 4Pi, yeah, with this it is over. So MPI 4Pi, you can use it for practicing MPI programs in Python. It is very easier. And I am having one more IIT Kanpur material for MPI 4. Basic only, that is also. That also I will share it. Okay. Any other clarifications?
Can you share some basic materials for Doja and GPU applications?
Yes. Actually, they share me one book, soft copy, that I will share. So now it's time for you to prepare. So at 12:30 sharply the exam will be there. 2 to 4, one more session is there. Okay. MCQ for them. Crafted hard copy MCQs will be distributed.
Open book test.
Hello, sir. Hello. Afternoon, sir.